For introduction, physics play an important role in understanding how objects move and interact with one another. One of the most significant contributions to classical mechanics was made by Isaac Newton through the formulation of Newton's law of motion. This law provides a comprehensive explanation of the relationship between force and motion and serves as the foundation of mechanics. Newton's law of motion consists of three fundamental principles. The first law explains the concept of inertia. The second law establishes the relationship between force, mass, and acceleration through the equation F is equal to ma. The third law states that for every action there is an equal and opposite directions. These laws are widely applied in various fields such as engineering, transportation, sports science, aerospace technology, and everyday activity. They enable scientists engineering to analyze motion, design machine, improve safety system, and solve practical problems involving forces and movement. For Newton's first law, there is law of inertia. The definition is Newton's first law states that an object will remain at rest or continue moving with a constant velocity in a straight line unless opened by an external force. This tendency of an object to resist change in its state of motion is known as inertia. For example, sit back in a car, a ball sitting still until kicked. As you can see, the mathematical representation is sum of net force is equal to 0. When the net force acting on object is 0, the object remains at rest or move with constant velocity. For real-world example is first, passengers in a moving vehicle tend to move forward when the vehicle stops suddenly because their body continues moving due to inertia. Second, a soccer ball stays still until kicked. And the last one is a book placed on a table remains stationary until someone pushes it. For discussion and calculation, example is a car with a mass of 1200 kg is moving at a constant velocity of 20 meters per second along a straight road. Determine the net force acting on the car. For constant velocity, we get A is equal to 0 meter per second square. Second, we have to using second Newton's law, that is F is equal to ma, m is equal to 1200 kg, a is equal to 0 meter per second square. Substitute the value, F is equal to 1200 multiplied by 0, and we got F is equal to 0 n, and the answer is the net force is 0 n.
Newton's second law. Newton's second law states that the acceleration of an object depends on the net force applied to it and its mass. The formula is F equal to ma. F stands for net force in the unit Newton, m stands for mass in the unit kilogram, a stands for acceleration in the unit m over s squared. So we can conclude that more force, greater acceleration, more mass, smaller acceleration. Acceleration is in the same direction as the applied force. Real-world examples. First, a man pushes a box, causing it to accelerate. Second, a shopping trolley moves faster when pushed with greater force. And the last one is a bicycle accelerates when the rider pedals harder. Next, we continue with discussion and calculation. So, question example is a man pushes a 5 kg box with a force of 20 n. Find the acceleration of the box. So, from the question, we know that force is equal to 20 Newton, m mass is equal to 5 kg. So, we use formula F equal to ma, a equal to F over m. So, a equal to 20 over 5. So, we get a equal to 4m over s squared. So, the answer for this question is the box accelerates at 4m over s squared.
Next, I would like to explain Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on another object, the second object exerts an equal force back on the first object in the opposite direction. For example, if object A push object B will also push object A with the same amount of force but in the opposite direction. These forces always occur in pairs and act on different objects. Therefore, Newton's third law helps us understand how forces interact with each other in many situations in our daily life. Now, let's look at some real-world examples of Newton's third law. The first example is a rocket launch. When the rocket pushes hot gas downward, the gas pushes the rocket upward with an equal and opposite force. This direction force is what allows the rocket to move into the sky. The second example is jumping. When the jumper pushes the ground downward, the ground pushes the jumper upward with an equal and opposite force. This direction force provides the upward acceleration needed for the jumper to leave the ground. These examples show that Newton's third law is not just a theory, but something that happens around us every day. For the discussion and calculation part, I choose this example because it clearly demonstrates the application of Newton's third law. The question states that a person with a mass of 85 kilograms is standing in a lift that is accelerating downward at 0.45 meters per second square. We are required to calculate the force exerted by the person on the floor of the lift. First, this is the force diagram for the situation. The weight W acts downward due to gravity, while the normal reaction force R acts upward from the floor of the lift. From the question, the given information is M equal to 85 kg, G equal to 9.81 meter per second square, and A equal to 0.45 meter per second square downward. Using Newton's second law, we obtain W minus R equal to MA. By substituting the given values into the equation, we obtain R equal to 795.6 Newton, which is approximately 800 Newton. According to Newton's third law, the force exerted by the floor on the person is equal and opposite to the force exerted by the person on the floor. Therefore, if the floor exerts an upward force of 800 Newton on the person also exerts a downward force of 800 Newton on the floor.
So the conclusion is, Newton's three laws of motion explain how objects move and interact with force. The first law describes inertia. The second law shows that the acceleration depends on force and mass. And the third law states that every action has an equal and opposite reaction. Together, these laws help us understand and predict motion in everyday life and scientific application. They can be observed in real-world situations such as walking, driving a car, riding a bicycle, and playing sports, where force continuously affects the motion of objects. Understanding these laws is essential for analyzing motion and solving practical problems in physics and engineering.